Welcome everyone. We are discussing integration. In the previous class, we have solved some problem which can be reduced to 10, 10 standard integral. Today, I will discuss integration by substitution method. So look, problem number 1, sin log x by x dx. So we know integration of sin x when argument is linear algebraic function. But here log x is not linear algebraic function. Therefore, we have to put a transformation to put it standard form. So for problem number 1, look, argument is log x. So we put log x equals to z. Now 1 by x equals to dz by dx. So this implies, look, 1 by x into dx. 1 by x into dx equals to dz. So here it is dx by x, so this is dz. So our main aim will be to write the problem in terms of new variable z. So integration sin log x by x dx. So sin z and this one is dz. Sin z dz. Now this is linear, so it is in standard form. So what is sin z? Minus cos z plus c. So minus cos of log x plus c. So this will be answer. Initially it is not in standard form, but using substitution method you can put it in standard form. So what is substitution method? Look, in this method, by putting some suitable transformation or substitution, the integrand, the thing to be integrated, the integrand is transformed into standard form. What is standard form? The previous problem, sin z dz. Then integrating we get primitive or integral. So listen, suppose problem number 2, a to the power m tan inverse x, 1 by 1 plus x square dx. So we know integration of a to the power mx is linear algebraic, but m tan inverse x, this is not linear. So put a transformation. So this argument as z. So let tan inverse x equals to z. You can also put m tan inverse x equals to z. So differentiating 1 by 1 plus x square equals to dz by dx. So dx by 1 plus x square equals to dz. So look, this integration a to the power mz dz dx by 1 plus z square. So now it is in standard form. In this method, by putting some suitable transformation, the integrand is transformed to standard form. This is integrand and this is standard form. Integrating we get primitive. What is primitive? The value of the integral a to the power mz by m log a plus a to the power mz by m log a plus c. Putting value of z, you get answer. So this is substitution method. Now for problem number 3, we have already discussed is e to the power 3 log x equals to e to the power log x cube, e to the power log x cube, 1 plus x to the power 4 whole to the power 5 dx. So x cube dx by 1 plus x to the power 4 whole to the power 5. X cube e to the power log x is 1. Now our main aim will be to put it standard form. Now you know 1 plus x to the power 4. If you put it at z, then derivative is 4x cube dx equals to dz. So x cube dx equals to dz by 4. Now look, this is dz by 4 and this is z to the power 5. So 1 by 4 outside, z to the power 5 dz. So putting some suitable transformation, it is transformed to standard form. So answer is 1 by 4 z to the power 6 by 6 plus 0. Then put value of z. Put value of z. So the transformation to be put will be clear from the argument. Sin log x. So log x minus z. This equals to z. Now listen, problem number 4. E to the power x, x plus 1 dx, cos square x e to the power x. So 1 by cos square is sec square. You know integration of sec square. When this argument is linear, it is not linear, so we put this equals to z. Now differentiating dz dx. So e to the power x common, dz. So dz by cos square z. So sec square z dz. So this is tan z plus c. Main aim is to put it standard form. Initially it is not standard form, but it is standard form. Tan x to the power x plus c. So this is substitution method. Now we consider 4 standard integral. We can, standard mean we can use this result directly. We know 10 standard, then 4. Integration tan x dx, log sec x plus c. Cot x dx, log sin x plus c. Sec x dx, log sec x plus tan x plus c. Cosec x dx, log cosec x minus cot x plus c. So log tan x by 2. So this result can be proved by substitution. So for example, suppose 1 tan x dx. So very simple, sin x by cos x dx. Now put cos x equals to z to get sin z. So sin x dx equals to minus dz. Omitting one step. So this is minus dz by z. So minus log z plus c. So minus log cos x plus c. So log sec x plus c. Cos x to the power minus 1. So this is, you may consult any standard book So very simple proof. Now suppose you have to remember the result. Now integration cosec x dx. So cosec means 1 by sine. If we put sine x equals to z, then numerator is 1. It is not in standard form. So we use this step. So we multiply numerator and denominator by cosec x minus cot x. Why we are multiplying it with cosec x minus cot x, it will be clear in the next step. So let cosec x minus cot x equals to z. So minus cosec x cot x, and this is cosec square x minus cot x derivative. So cosec x common, cosec x minus cot x into dx equals to dz. So we are getting the numerator. So that is why we are putting the very substitution. So after this it will be dz by z. This is dz, so log z plus c. So log cosec x minus cot x plus c. So this is first form. So if you write it in terms of sine and cos, you get the second one. So log sin x LCM 1 minus cos x. So log 2 sin square x by 2, and this is 2 sin x by 2 cos x by 2 plus c. So log tan x by 2 plus c. Cancelling, you get result. So we consider these results as standard. So tan x, cot x, sec x, cosec x. Now application. Now application of these results. So these are all 1 marks problem. 1 marks problem. Now look, we know integration of tan when argument is linear algebraic. Now e to the power x is not linear. So what is transformation? E to the power x equals to z. So e to the power x dx equals to dz. So this transform to, look, tan z dz. Then we do not give the proof of this. So use direct result. So this is log sec z plus c. So log sec e to the power x plus c. Initially it is not in standard form. By putting some transformation, you can put it standard form. So this is 1 marks problem. Now 2 sec 2 tan inverse x by 1 plus x square. So what is argument? 2 tan inverse x. This is not linear. So 2 tan inverse x equals to z. So 2 by 1 plus x square into dx equals to dz. So dx by 1 plus x square equals to half dz. So dx by 1 plus x square. Now this one is, after this step, sec z, and dx by, this is dz by half. So half of integration sec z dz. Now it is in standard form. So half of, look, sec z. Put any one of the formula, sec z plus tan z plus, and where z equals to, you put value of z. Similarly 3, You solve it. So log x equals to z because this is not linear. Now we consider 1 to 5 problems. So they are of 2 marks problem, very simple. Actually, if you know the derivative and you can apply the substitution, then it is very, very simple. So problem number 1, log x sine 1 plus log x whole square by x. So main function is sine. Now this argument is not linear. So we have already stated you have to put argument equals to z. Let this equals to z. Now derivative. Derivative of log x whole square. 2 log x into 1 by x equals to dz by dx. Function of function. So log x by x. What is log x by x into dx? Dz by. It is in the form log x by x. So after this step, you look sine z. It is sine z and log x by x equals to dz by. So half outside sine z dz. So minus half cos z plus c. So you have to put exact that is suitable transformation. So half cos z, put value of z, you will get result. Now for 2, look, think 5 to the power. So our standard form is, you know this integration, a to the power x dx, a to the power x by log a plus c. So this is linear. So 5 to the power x plus tan inverse x. It is not linear. So what is transformation? X plus tan inverse x equals to z. So 2 plus x square. So look, after this 5 to the power z and this is dz. So this argument as z. So it is in standard form. So put the value 5 to the power z y log z plus, log 5 plus c, where z equals to this. You put value of z. So integration, it is considered as inverse process of derivative. So to perform integration, you need how to differentiate. So number 3, sin 2x by a square sin square x plus b square cos square x whole square. Now, if we consider sin 2x is equal to z, so we are not getting this one. So we try by putting this transformation equals to z. So a square sin square x plus b square cos square x equals to z. So derivative 2 sin x into cos x plus b square 2 cos x into minus sin x equals to dz by dx. Derivative of function of function. So this is sin 2x, this is also sin 2x. So a square minus b square into sin 2x into dx equals to dz. So what is sin 2x dx? dz by a square minus b square. So look, we are getting sin 2x. So after this, it is dz by a square minus b square, and this is z square. It is outside z to the power minus 2 dz. So this is our main aim, to get standard. So we are getting standard form, z to the power minus 1 plus c, then put value of z. Next, this one is simple. So you put 1 minus tan x equals to z. Exactly same. This is sec square x. So you get result. Now 5 sin 2x by a plus b cos x whole square. Sin 2x by a plus b cos x whole square. So this is cos 2x, we are not getting result. So a b cos x equals to z minus b sin x dx equals to dz. So sin x dx minus dz by 2. Now sin x. So if you write formula, so we are getting 2 sin x cos x by a plus b cos x whole square. Now this is important problem. So sin x dx equals to dz by this. Now you are getting 1 cos as x square. Now what is value of cos in terms of z? Z minus a by b. So look, 2 unchanged. What is cos x? Z minus a by b. So this is cos x. Now what is sin x dx? Sin x dx is minus dz by b. Then this one is z square. Z square 2, value of cos x, sin x dx. So minus 2 by b square outside, z minus a by z square dz. So minus 2 by b square is outside, 1 by z minus a into z to the power minus 2 dz. So this one is standard. This is log z. And this is a into minus 2 plus 1 minus 2 plus 1 plus, where what is z? A plus b cos x. So you put suitable transformation and perform integration. Now we consider 5 problems. So dx by e to the power x plus 1. First one, dx by e to the power x plus 1. Now if we put this equals to z, this is not linear, then it is log. If we put e to the power x equals to z, so derivative of e to the power x is e to the power x. E to the power x dx equals to dz. So e to the power x, so what is dx? dz by e to the power x. Now we want to express it in terms of z. So what is e to the power x? Z minus 1. So e to the power x is z minus 1. So what is dx? dz by z minus 1. So 1 by z e to the power x, this is z, and this is dz by z minus 1. So this is not in standard form. But look, we can write it in this form as a difference of this. So z minus z plus 1. So meaning remaining same. So we can write it as log z minus 1 minus log z plus c. So log z minus 1 by z plus c, where z equals to e to the power x. This is one method. So you can indicate it, you can indicate a problem by various methods, many methods. So look, second option, if we multiply numerator and denominator, if it is x, then e to the power minus x. So multiplying numerator and denominator by e to the power minus x. Then what advantage we are getting? Now 1 plus e to the power minus x equals to z. dz dx. So e to the power minus x dx equals to minus dz. So look, you are getting minus dz by z. So minus log z plus c. So log 1 by z plus c. To avoid minus, so what is z? 1 plus e to the power minus x plus c. Then you can write e to the power minus x as 1 by e to the power x. Simplifying, you get result. Our main aim is to get standard form. So second one, multiplying by a to the power minus x. Now 3, 4, 5, they are of same type. So 3, 4, 5, they are of same type. Suppose problem number 4. Our main aim is to put the integral in standard form. So it is 2 to the power x. So you multiply numerator and denominator by, if it is x, then minus x by 2. So this step to be noted. Now for this problem number 5, you have to multiply. This is 2x, so 10 to the power minus x. So what advantage you are getting? Look, by rule of indices, you are getting this. Now if we consider denominator as z, then we get numerator z. So derivative of 2 to the power x by 2, 2 to the power x by 2 log 2 into half, 2 to the power minus x by 2 log 2 into minus half equals to dz by dx. So 2 to the power x by 2 minus 2 to the power minus x by 2 into dx equals to 2 dz by this half, it is multiplied to here 2 dz by log. So 2 to the power x by 2 minus this equals to 2 dz by log 2. Log 2 is constant. So you are getting, look, 2 dz by log 2 by z. So 2 by log 2 outside, dz by z. So 2 by log 2 into log z plus full value of z. So you remember the method. If it is x, you are multiplying it by e to the power minus x by 2. And problem number 5, you have to multiply it 10 to the power minus x. 10 to the power minus x. Simplify and put denominator equals to z. So you solve. That is 2. Now we consider finally 1, 2, 3, 4. Consider the last one. So 2, 2, 2. Yes. Now we can integrate 2 to the power x when it is linear. Now 2, this one is not linear. So obvious transformation is this equals to z. Let this equals to z. Now derivative. Base is 2. So 2 to the power x into log 2 into ddx of argument 2 to the power x. 2 to the power, this one unchanged, into log 2. Base is 2, so this is log 2 ddx of argument. Again 2 to the power x into log 2, and at the beginning there is a log 2. So log 2 whole square equals to dz by dx. So again it is log 2, so log 2 whole square. So what we are getting, you look, this part, what is value, equals to dz by log 2 whole square, and dz by log 2 whole square. Now this one is 2 to the power z, 2 to the power z. This is z. We are considering this power as z, and this equals to dz by log 2 whole square. So 1 by log 2 whole square unchanged, 2 to the power z dz. 1 by log 2 whole square unchanged, so 2 to the power z, 2 to the power z by log 2 plus c. So finally log 2 whole cube, 2 to the power z. Put value of z and get value of the integrand. Next, now problem number 3. dx by x plus 1, and this is, look, x plus 1 whole square plus 1, x square plus 2x plus 2. So we put a transformation to make it standard form. You know, if x square plus s1, we get x equals to tan theta. So here x is replaced by x plus 1. So trigonometric transformation is x plus 1 equals to tan theta. So what is dx? Sec square theta. So sec square theta d theta. X plus 1, this is tan theta. This is tan square theta plus 1. So cot theta d theta. 1 plus tan square theta is cancelled. You are getting cot theta. So this one is standard form. So this is log sin theta plus c. So log tan theta equals to x plus 1. Tan theta x plus 1. So this is x plus 1. This is x. Sorry, this is 1. And this is root over this square plus this square, x square plus 2x plus 2. So what is value of sin theta? Perpendicular by x square plus 2x plus 2 plus c. So this is our main aim, to put it in standard form. Now these two are of same type. So consider problem number. Now you can put tan theta, but this is tan square, sec square theta to the power 3 by 4. Root is not eliminated. So that is why we use alternative. Look, x square. If you take x square common, x square 1 by x square whole to the power 3 by 4. So dx by x square unchanged. So x square to the power 3 by 4. So I think this is x4. So you correct it, x4. So x4, 1 by x4. So x4 to the power 3 by 2. So this is x cube and 1 plus 1 by x to the power 4, power is 3 by 4. Yes, correctly it is x to the power 4. Otherwise it will be not in standard form. So this is dx by x to the power 5 dx by x to the power 5 1 plus 1 by x to the power 4, power is 3 by 4. Now we put a transformation. 1 plus x to the 1 by x to the power 4 equals to z. So x to the power minus 4 into x to the power minus 5 dz by dx. So 1 by x to the power 5 dx equals to dz by 4 with negative sign. Now look, it is in standard form. Dx by x to the power 5 minus dz by 4, and this is z to the power 3 by 4. So minus 1 by 4 z to the power minus 3 by 4 dz. So finally minus 1 by 4 z to the power minus 3 by 4 plus 1 by minus 3 by 4 plus 1 plus 3. So putting value of z, you get value. So it will be x to the power 4. Now first one, you have to take x to the power 4 common. X to the power 4 common. So if you take x to the power 4 common, so x to the power 4, 1 minus 1 by x cube, total power 1 by 4 by x to the power 5. Now this is x, this is x. So 1 by x to the power 4, x and x to the power 5. 1 minus x cube whole to the power 1 by 4 dx. Now this one equals to z. So put the transformation and you get it in standard form. So integration by substitution. This is most important chapter for integration. So I will take 2 more classes of this chapter. So through this video today I have discussed basic problems of integration by substitution method. So thank you for today. Thank you.